Okay, let's look at this question on similar triangles. So it's from the 2013 paper 2. Question 11. The two triangles shown are similar. Okay, so that's good. We don't have to prove that they're similar. It's told us they're similar. And it's asking us to find the value of x, okay, which is the length of this side here. So find the value for x. Okay, so similar triangles. Okay, so we looked at the theory there. So remember, their angles are equal. And if their angles are equal, their sides are in proportion, which means one triangle is an enlarged triangle of the other. Okay, so to figure out which side is in proportion to which on the triangle, you must rotate one of the triangles. Now I'm just going to rotate this one, rotate this triangle so that it is in the same direction as this one here. Okay, so let me draw a circle around him and I'm going to rotate him over here. So now apologies in advance for how bad my drawing is going to be. Okay. So I've literally just rotated that diagram anti-clockwise. I turned it backwards, okay, so that this angle here matched up with this angle here, okay, because that's what they're showing me in the diagram. They're showing me that they are the two angles that are matched. Now, because these are similar triangles, I also know that this angle here matches another angle on the triangle. It didn't have to tell me, because once I align these two, then I know that that angle is the same as that one. And I also know that the third angle here must now be the same as that one there, because that is all being told to me by the question telling me that they're similar. Similar triangles have angles that match, that are equal, okay? So they told me this one matched this. I rotated the triangle and now I know which angles are which. Now I must match up the sides. So what I'm doing here is I'm turning around my tablet and I'm looking at this triangle in this direction. So in other words, I'm moving around my tablet so that that angle is now on my right. And when I do that, I can see that I have 15 on the bottom, okay? And I can see that 6 is here on the right. Now, some people are really good at seeing that, and especially if you do any of the tech graph or drawing subjects, you will most likely be able to see that very easily, okay? If you don't do them, then you have to do what I just described and turn your tablet and make sure that you can see it, or turn your page or whatever you're writing on. Okay, so what is the benefit of this? Well, I know now that this side is in proportion to this. I know this side is in proportion to this one, and I know this side is in proportion to this one. Okay, and I know that because I've lined the triangles up so that that is the case. Okay, I'm going to label my corners of my triangles, or my vertices of my triangles, just to make it easier to describe them. Okay, so the similar triangles theory tells me that their sides are in proportion. So what does that mean? Well, that length of the side AB over DE, when I put one of those sides over the other, I'm going to get the same answer as if I put BC over EF, because those sides are in proportion. And that's going to get the same answer as if I put AC over DF. Okay, that's what it means by their sides are in proportion. You take the side of one triangle over the matching side of the other triangle, and so on all the way across, okay? Or I could have written it as this triangle on top, okay? So DE over AB being equal to EF over BC being equal to DF over AC. Okay, it doesn't matter which way you write it, as long as if you start with the big triangle on the top, the big triangle stays on the top all the way across. Or if you start with the small triangle, the small triangle stays on the top all the way across, okay? Because you're either saying this triangle here is smaller than this one, or you're saying this triangle is bigger than this one, okay? But what you can't do is put some big on the top and some small on the top. You can't do that, okay? So it doesn't matter which way you do. I'm just going to leave it as the first one I wrote down. And now I fill in the sides that I have information about. So there's my X in AB. So I definitely need to fill him in, okay? Because that's the side I need to find. And what you'll find is you tend to take just two pieces of the triangle. We never really take three because you can't work with three anyway at the one time. So we take two. So AB over DE. So that's 6 equals BC. Well, I don't know anything about BC. I don't know anything about EF. Okay, so that's no good to me. So let's come over to AC. Well, I know he's 25 over DF, which is 15. Okay, so there's the two pairs I'm going to take. At this point in time, what we do is we cross multiply so we can solve. So when you cross multiply, you're allowed to do that only when the equals to sign sits in the middle. Okay, and what it does is it gets rid of fractions. So you say that either x times 15 or 15 times x, it doesn't matter the order that you read it in. So I'm going to come over here, 15 times x is equal to the other two bits multiplied, and that's why it's called cross multiply. So 6 times 25. And that's lovely. It's a lovely thing to do because, as you can see, it's got rid of all of the fractions here for me. Okay, let's, like any other algebra, let's work it out. And like any other algebra, divide by the number in front of the letter and solve for x. So I am finding that x is equal to 10. Okay, so that's how you do it. Can we check it any other way? Well, yes, again, if you have a drawing head on you, if you can see it, you can think about it as using a scale factor, okay? And I'll just show you how that works. So when you compare the sides, so we'll say 15 and 25, you can say, well, the scale factor, how much times bigger is the 25 over the 15? This is what you call your scale factor. So in other words, how much bigger are you going to draw this triangle than this one? Okay, well, you're going to draw this one a factor of 5 over 3 bigger than this one. So therefore, you need to take that side 6 and you need to multiply it by the scale factor, and you'll also get 10. Okay, so that's not the official way of doing a similar triangles question. You should do it this way, but it is a great way of checking your answer on your calculator, you know, if you're lucky enough that your brain thinks in that type of a way. Okay, we'll end up doing a bit of that anyway in enlargements, but okay, so that's just linking it all together. So this is the similar triangle theory, and this is how you use it.